Question number 6. Again, a question related with the probability. 3 events we have, A, B, and C. And probability of A is given 0.1. Probability of B given A is 0.3. It's a conditional probability. Probability of A union B is 0.25. Probability of C is 0.5. Given that A and C are mutually exclusive. Probability of A union C. That is the first question. So the concept is, if A and B are two mutually exclusive events, probability of A union B is always probability of A plus probability of B. That means probability of A intersection B is always 0 for mutually exclusive events. So here our events are what? A and C. A and C are mutually exclusive. Given A and C are mutually exclusive. Therefore, probability of A union C means it is what? Probability of A plus probability of C. So what is probability of A union C? Because probability of A is given and probability of C is also given. So substitute it. 0.1 plus 0.5. So answer is 0.6. So answer for this question, we got it as 0.6. Now move to B question. Show that probability of B is 0.18. We need to show that probability of B is 0.18. So what all things are given here? Probability of B given A is given. So according to the definition of probability of B given A, it's a conditional probability. We will say probability of B intersection A divided by probability of A. So what is probability of B given A? B given A is 0.3. So 0.3 is probability of B intersection C that we need to calculate. Probability of B intersection A divided by probability of A. Probability of A is 0.1. So cross multiply. So probability of B intersection A is 0.3 times 0.1. So that is 0.03. So what is the advantage of knowing probability of B intersection A? Because it is given in our question that probability of A union B. So probability of A union B, because A and B are not mutually exclusive events, right? So if this is the case, generally what is the formula for probability of A union B? Probability of A union B is probability of A plus probability of A B minus probability of A intersection B or B intersection A. The probability of A union B, it is given. What is probability of A union B? It is 0.25 is equal to probability of A. We know that is 0.1, but we don't know probability of B. But we already calculated what is probability of B intersection A. That is 0.03. Then you can use basic algebra to find or make probability of B the subject. So 0.25 minus 0.1 plus 0.03. So 0.25 minus 0.1 is 0.15. 0.15 plus 0.03, 0.18. So probability of B, we got it as 0.18. Hence, shown. So A question, B question we did. Given also that B and C are independent. So what is given in the C question? B and C are independent. So if two events B and C are independent, then probability of B intersection C is probability of B multiplied by probability of C. So if two events B and C are independent, probability of B intersection C is exactly equal to probability of B into probability of C. So what is probability of B? We got it as 0.18. What is probability of C? That is 0.5. So 0.18 multiplied by 0.5. So we will get it as 0.09. So probability of B intersection C, we got it as 0.09. Now using all this, we can draw the Venn diagram, because our ultimate aim is to draw a Venn diagram to represent this probabilities associated with this. So we will draw a box that represents the universal set, and we have three subsets, event A, and then we will draw three another subsets. This is event B, then this is event C. So why we are not drawing in the usual way? Usually, if three subsets are then we will be merging all the three sets together, and we will draw something like this. This is how usually we are drawing for three subsets. But here we are not using that idea. What is the reason? Because it is given that nothing is common between A and C. So that is why we don't want to show the intersection between A and C. So this is B, this is A, and this is C. So what is common for A and B? That is A intersection B. So A intersection B is 0.03. 0.03. What is B intersection C? That is 0.09. And what is probability of B? Probability of B is 0.18. So 0. Probability of B is 0.18. So if this value, if you are keeping it as X, so X plus 0.03 plus 0.09 is 0.18. Therefore, the value of X is 0.18 minus 0.09 minus 0.03. So if you are doing so, we will get 0.06. So here this value, we got it as 0.06. And let this value, we will keep it as Y. So Y plus 0.03 is probability of A. We don't know why 0.03, but what is probability of A? Probability of A is 0.1. Therefore, Y is 0.1 minus 0.03. Therefore, this value we obtained as 0.07. Now, let this value, we can consider this as Z. This we can consider it as C. So, probability of C is 0.09 plus Z. So, probability of C, that is 0.5. So 0.5 is 0.09 plus C. Z value is 0.5 minus 0.09. And that value, you will get it as 0.41. So this 0.41. Now you cross check whether this all adds up to 1 or not. If that is not adding to 1, then something we have to keep outside the bracket, because the total probability is 1. So 0.07 plus 0.03, that is 0.1. 0.1 plus 0.06, that is 0.16. 0.16 plus 0.09, that means 0.25. 0.25 plus 0.41, that is 0.25 plus 0.41, that is 0.66. So altogether it is 0.66. 1 minus 0.66, that is 0.34. So we'll keep 0.34 because The outside part is 0.34. So that is the completed Venn diagram for this. So again, question number 6 was also a very simple question. It is related with the probability and a Venn diagram. Hope you got the idea regarding this.